Hello everyone, this is Shashidhar on behalf of Edureka. In this video today we are going to learn about Talend Components. So let's see the agenda of this video. So today we'll be discussing again a brief introduction about Talend, and more focus will be on the Talend components. What is component? What are the different families of components available in Talend? How they are used? And then we'll move on to specific components which are widely used, that is file components, and then processing components, and then database components. So at the end of this video, you should be able to understand what is component and use the file processing and database components for simple use cases. So let's move on. So what is Talend? To give an introduction about it, Talend is an open source data integration platform and also a vendor. It is also a company which provides you all these data integration tools. Not only Talend DI, but then big data, data preparation, all other products Talend will provide for all our data needs. It provides various software and services which helps companies to become data driven. Everything about data, Talend has a tool for you. It helps organization in taking real-time decisions. You put given all the data, whether it can be master data management or your sales trend or your business management decisions can be taken over your data, analyzing over it. So Talend helps you to do that in a better way. So it enables customers to adopt new innovations and scale to meet market demands. So recognized as leader in the Gartner Magic Quadrant, so it is in the quadrant of leaders actually. So it is giving very tough competition to the market leaders like Informatica and DataStage. Since it is very user-friendly and Java-based, it has got the position in Challengers Quadrant in very less time. So that's Talend for you. So what are Talend components? What actually a component means? We have also been telling about Talend and components in our previous videos as well. So today we are going into a very deep dive into the components topic. So what is Talend component? It is just a piece of Java code. Whenever you drag and drop any of the component into Talend design workspace, it will generate the Java code which is required to do that work of the component at the backend. And where do you find the components? The palette is a place in Talend. There will be a window called palette window as you see in this slide. So in this window, we'll be able to find all the components who are organized into groups. And again, it is a snippet of Java code that is generated when job is executed. And Talend provides you more than 900 components in your Talend DI, and in your big data, Talend big data, you will have big data components as well. So all these standard components is widely used, and we'll be taking which are very required components like, as I mentioned, that is file components, processing components, and database components. So as I said there are more than 900 components, but then it should be in groups, right, for us to understand what category they belong or what family they belong. So they are broadly classified into so many families, that is big data, it can be business intelligence, it can be ETL, or logs and errors, orchestration, processing, or it can be XML related, or it can be cloud related, or MDM related, or system related. So they're all divided into different families, and each one component can fall into different families as well. So let's move on to file components now. So for example, how Talend components are named is it starts with a letter T, and what is the format of it, whether it's a file, whether it's a DB, what is that we are having as a component. And then the next set will be like whether it is an input component or an output component. It will be named like that. And after that, the format of the file, whether it's an XML file, delimited file, Excel file, whatever it is. So tFileInputExcel is the component name which will be used to read an XML file. So whenever I use this component, if I provide file name and if I tell whether it is XLS or SLXS, it extracts the data line by line. So when I drag and drop this component, I'll be able to read the Excel file which is available in my system line by line. So we'll be showing you in the demo like how we can use this component as well. But then first understand how it is named and what is this component for. So it opens the file and reads it row by row in order to split up the data into fields using regular expressions. Like you can create the schema, read line by line. If you want to filter out, you can filter out. Everything can be done in Talend. So using the row link, whenever you right click on any of the component, the way the data can be taken out of that component after reading. So it will be in the main row. Using that main row from this component, I can take the data out of this and I can transform it, filter it, whatever I want, I can do it over there. So tFileInputExcel is a component which helps me to read an Excel file in XLS or XLS format line by line. So that is a usage of this component. So let's look into other widely used component. This is one example for an input component. So the next one we are seeing is tFile. So it is an output related. Previous one was InputExcel, and this one is output and delimited. So as the name suggests, it's a output component which is a delimited component. So it is capable of generating a delimited file. So it can be used to read whatever data you are giving it to this component. It will create a delimited file in the place where you provide, like where do you want to create this file. By using tFileOutputDelimited component, I'll be able to write the data into a delimited file, like where it has to be created and which should be the delimiter for that file. If I provide those inputs to this component, it should be able to create a file in that path with that delimiter. So this is one of the output component. It can be creating the output file with the delimiter which I provide. So let's move on to the next widely used file component. So it is called tFileList component. So tFileList component helped me to iterate through directories, subdirectories, and give me the list of the files which are available. The input I'll give for this component is path of a directory, and it will go through all the files and subfolders inside the directory, and it would give me the result. And that also I can configure whether it has to go to subfolders or not. So it retrieves the set of files and folders based on the particular file mark. Suppose I want to only filter out the error files and then archive it or delete it, then the tFileList will help me. So dynamically I can get the file names in a folder. So using this component, you can even iterate the subdirectory elements as well. And the next widely used component is tFileExists. So whenever we are looking for a file, suppose we are waiting for some file or something like that, so we'll have to check on whether that file is existing or not. We may be expecting one file in one server path arriving today, but we are not sure whether it has arrived or not. So we should be always checking first whether that file is available or not, and then we'll have to move on reading that file or something like that. So this component helps me in checking whether the file exists or not. So it helps in streamlining the process by automating the tedious task like checking if file exists. So we can schedule a job for every 10 minutes and it checks the file. If it is available, it will continue. Otherwise, it will logically end the job. So this component can be used as a standalone component. So it doesn't need any external input to be worked upon. It just needs the path of the file, name of the file. It has to check whether it is existing or not. So next widely used component is tFileCopy. So whenever I'm done with processing or something like that, I will have a need to move the set of files to another folder or copy them. So for copying, we have a component called tFileCopy. Very simple thing as the name suggests. So this component helps in copying the source file to the target file, like the directory, wherever it has to move. It helps in streamlining the process by automating the recurrent and tedious copy tasks. So this component can also be used as standalone. It needs only the source directory and the destination directory. Once the execution is completed, all the source directory files again mask can be given, so it can be moved to the target directory. These are the widely used file components. We'll be seeing the examples in the demo. So now let's see what are the widely used processing components. Let's see what is the first processing components. So tMap is very widely used component in Talend because it is multi-purpose and very user-friendly to configure. So this is an advanced component which is integrated to the Talend Studio as a plugin. So it helps in transforming and routing data from single or multiple sources. It can be heterogeneous sources to a single or multiple destination as well. Again, destination can also be heterogeneous. You can read from Excel and XML file. You can put it to a database and a normal delimited file. So that's the capability of it, and it can do filtering, it can work on expressions, you can create temporary variables. There are many features which tMap provides, which I'll be demonstrating in the demo as well. It is used for simple reorganization of fields, and most complex data transformation can happen in tMap. So tMap is one of the widely used component for processing. So next we have tJoin. In tMap also, it can be used for joining one or more heterogeneous sources. So, but tJoin does the same job as well. So this component helps in joining two tables, doing an exact match on the several columns. So it is used for joining alone, but then it cannot filter out or change the number of fields, something like that, which tMap does. So it is a light component. What I mean by light component is the number of lines of code for tJoin is less than the number of code of lines for tMap. So tJoin can be used only in the place where our requirement is only to join and not to do any other filtering or other expressions is not needed. So it compares the column from the main flow with reference columns from the lookup flow and outputs in the main flow for rejected data. So it gives you two output, one with the joined and another with the reject. So it ensures the data quality of the data from any source against the reference data source. So in a join, whenever you're choosing, it ensures the requirement. So let's move on to next component, which is tFilterRow. Again, the naming convention is like T and what action does it perform. So whenever you think of filtering and whenever you think of sorting, you can just go and type in the functionality in the palette and you will get the component for it in Talend. So basically, as the name itself suggests, it is used to filter the rows. So it helps in filtering the source data for more than one conditions, and you can also put condition more than one column with and or conditions. So it helps in parameterizing the filters on the source data and incoming data. The schema of this component is read only. Like whatever you are taking, whenever you are taking the source data, same schema will be copied along with one error reason. Like whenever your filter data is rejected, you should know for what reason it is rejected. So maybe I'm giving 5 conditions. I got 5 rows rejected. All 5 rows can be rejected for different reasons. I need to know the reasons, right? So there'll be one read-only schema in tFilterRow, which is error message. So let's move on. As I said again, the functionality, the sort, tSortRow, as the name suggests, it will sort your input source data, which is coming into tSortRow in ascending or descending order. And it can sort your numbers, it can sort alphabets, it can sort date for you. So this component is defined as an intermediate step as it requires input and output to handle the flow of the data. So it helps in creating the metrics and classification table. Like whenever you want to do a sorting rank operations, you can use for tSortRow. So the next component, these are the widely used processing components. I'll show you them how does it work and how we have to configure them in the demo. So now let's see what are the widely used database components. And for database, there are many databases which are supported in Talend, but for demo purpose, we have taken MySQL. So let's see what are the different components which are widely used. So database components, this family provides Talend components which cover various needs like opening the connections, reading the table, committing, performing rollback, error handling, and capture how many lines has been inserted, how many lines has been updated, deleted. So those stats as well. So more than 40 RDBMS are available. So it's Amazon, Azure, Postgres, Sysbase, whatever you name. So MySQL is what we are taking as an example here. So the first component is the connection component in database components, which is widely used, which can be reusable in the job or whenever it is created in metadata, it can be reused across the jobs. So this component is nothing but it helps in creating your connection for the database for a current transaction. So it is used to open the connection which you have specified and it can be reused in the job. So if I'm using more than one input database or one output database components in my job, in each component I'll have to define the connection thing, right? So instead of that, I can create the connection component which will be reused for all my input and output database components. So let's see the next component. So tMysql input. So as the name suggests, as we saw in the tFileInputDelimited or tFileInputExcel, so this component helps in reading the database and extracting the fields based on the query. I can query a table using this component. So it executes a DB query within a strictly defined order, which must be corresponding to the schema which is existing. And then, as I said, whenever we right click on any of the component, we'll get the main row or the iterate. So using the main row, I can read the data of tMysql input. So in tMysql input, there'll be a configuration where I can say you use the connection which was created by tMysql connection component. So it does not end up in creating another connection for input alone. So similarly, we have tMysqLRow. So this component is to whatever scripts you want to execute, ad hoc scripts, or you want to drop all the indexes before loading a huge data. And then once the loading is converted, you want to recreate the or enable the indexes. So in such cases, you can use all this tMysqLRow component, wherein it acts as an actual DB structure on the database and the nature of the query in the database. So it will just execute the query which is available inside this component. So I'll just have to tell which connection again and what is the query that has to be executed. So it will execute that query. So the next component is tMysql output component. So again, similar function only. So whatever data is coming in, with that data, it will be capable of creating a table and loading that data inside the table created. And there are multiple actions can be performed, like whether the incoming data should be updated or inserted or deleted. So all those things can be managed by tMysql output. So connection, input, DB row and output are the widely used components in database family. So now let's see a demo on all these components. A simple demo I'll be showing how to use this component or how to configure these components. So let's proceed to demo. As you're all aware and as we have been telling in the previous videos, So downloading and starting Talend is very simple steps. You can directly go to talend.com and download the open source Talend data integration tool. It will be a zip file when it is downloaded. Once you extract the zip file, it is nothing but it will have all the executables for different operating systems, like the separate executables for Windows and Linux. So based on your operating system, you can just launch the executable of Talend Open Studio and you can start working. The only prerequisite needs is the setting of Java should be installed and it should be configured, like environment variables should be set. That's the only prerequisite. So you can simply go to talend.com. So I can just click on download section here. So you can just click on download free tool for Talend data integration and then your tool will be downloaded as a zip file. So it would look something like this. So we'll have to extract this zip file. So I'm using Talend Open Studio for Big Data 6.4 version. So Talend Open Studio for Big Data is a superset. So it has all the contents of Talend Open Studio for data integration along with big data components. So if I download Talend Open Studio for Big Data, it is as good as downloading your Talend data integration for DI as well. So you can download the Talend Big Data version as well, whichever you want to work with. If you are not dealing with big data, it is better to install only Talend data integration. But for the demo purpose, I'll be using Talend data integration for big data, which is having all the features of Talend data integration as well. So I'll just go inside the extracted folder. And as I said, all the executables will be available. Since I'm using Linux, I'll go with Linux executable and double click on it. So once the Talend is launched, you'll see all the windows open here. Most of them will be inactive. Once you create the job under repository, under job designs, all the inactivated windows will get activated. So let's create a new job, say job 1 component demo. So purpose and description you can fill as per your requirement. So once you have created the job, so it will open a designer window for you along with activating all other windows. So now to show you the demo on the components which we have seen in the PPT. So let's take one of the example, like I have an employee details file with me. So I'll have to read that file. That is the first example which we saw for reading an Excel file in the input components family. So to read that file, the component which we had learnt is tFileInputExcel. So either I can drag and drop the component to my designer window and I can configure them by double clicking on it, and in the component window I can give what is the file name, and the most important thing is the schema of it. What is the column names which I have to be read from this file. So this has to be either created manually or we can create metadata. So let's go with the metadata approach, which can be reused. So under repository, under metadata, which file are we going to create the metadata for? It's tFileExists. So I'll just say create tFileExists and I'll say metadata for emp1. So I have another lookup file as well. So I'm naming this as emp1. And then I would provide the path of that file. So emp details1 excel sx. This is the file. So I'll also show you how does this file look like. So once I give it to the file path, and then it has already recognized this as XLSX, and this is the data which I have in the file: employee ID, employee first name, employee last name, and employee date of joining. So this sheet I'm going to read. So it will automatically read the file and prepare the structure for me. That is the usefulness of the metadata. So as you saw there in the previous window, even the column name has been treated as data. So I can just say either header 1 row, or there is a customize option here saying set heading row as column name. So I'll just click it. So automatically header 1 will get populated here. So then I can refresh the preview. So the first line will be treated as header, then the data follows. And just to show you how to review and make changes, we have added one empty column next to the proper data. Talend will also read it, like how we are seeing it has read ID, first name, last name, date of joining, and it also has read the empty column. So in the next step, whatever changes we want. So it is just like providing review for us. If you want to change any data type, any length, or if you want to delete a column or something like that, you can do it in the review step and finally create the metadata. So my ID is being populated as integer and all others as string. That's fine for my demo. but I don't need this empty column, so I'll remove this. So my metadata is ready now. So now either I can give reference of that metadata here by choosing repository and telling which metadata to refer. That could be one step, one way of doing it. It will point to the metadata which we have created. Another way is I can directly drag and drop the metadata into my designer window. It will come up with all the pre-populated data including the file name. So whenever you want to use the same structure on different file names, you can change only the file name. So once you drag and drop, it will give you a list of components where you can use this metadata. Like it is only the structure related thing and the file properties, right? So it can be used in the input as well, also output. So we'll select input component as per our requirement. So my requirement at the first step is to read the file. So now this component has all repopulated data. It has the file path as well, and it also has the metadata reference. So if you can see the schema will be pre-populated. So let's read this data. I can just put it to console window all the data by choosing a component called tLogRow. By just clicking on the designer window and typing out the component name also will allow you to get the component inside the designer window. So now I'll right click on the tFileInputExcel component, choose row option and main to select the data flow. And I'll give it to the output component called tLogRow. So this will automatically copy the schema however it is coming from the input, and it just output the data in table format. So I'm choosing the data to be printed in table format here, and then I'll just run this job. So this simple job will be able to open the file which you have given, read the data row by row, select the first row as header, and then populate that data into console by using a tLogRow component. We'll be able to see the output in the console here. So we'll be always getting the real-time statistics as well over here, how many rows has been passed. Now we can see all the data in that file has been populated in console here. So this is how you can use an input component to open the file and read the data line by line. So this was our first input component which we had learned. And the next file component we saw was tFileOutputDelimited. So as we have read the data from Excel and we have just displayed the data in the console, we can now pass on this data to a delimited file. So I can tell tFileOutputDelimited. So I can just take the main row from the tlog as well, or I can take it from the previous component also. If you want to remove this log, we don't want to print it in the console. So now I have to choose where I have to create this file. So let me choose Edureka demo output, and we'll create a new file saying emp data delimited.txt. So we'll generate a text file with pipe delimiter as the delimiter and /n as the row separator, and we can just copy the schema from the input component. No need to again create a metadata for it. So it will automatically take the structure which is coming from this link. So with this simple settings, we'll be able to pass on the data from an Excel file to the delimited file. So now let's run this job. Now the job has been executed. So let us see whether this file has been generated or not. So in the demo output folder, data delimit.txt. So this one will open. So from Excel, we'll be able to load the data to a simple delimited file. So now we can see all the data is available over here in the file which we have created with pipe delimiter. So with this simple steps, we were able to read a Excel file and transfer the same data into a delimited file. The next component we saw in file family was tFileList component. So tFileList components, as we know from the PPT what we gone through, it will help us to read through directories and subdirectories and give us the file information over there with also the mask option. So let us create another job use case for tFileList. So let me name it as J2 component demo. I'll provide the same purpose and description. Suppose I had a requirement to have similar structure day by day data or month by month data as a separate files in a directory. I'll have to read through all the files and give that data to some processing or put them into one single file. Basically going through all the files in the directory and merging them into a single file. So if that is the requirement, tFileList will help me out in putting down the solution for it. So let's see how does this work. Let us create 3 files and we'll append them. So suppose in demo input, I have 3 files called day1, day2 and day3, which has employees details which I have got on date 1, the same employee data which we used in previous example. And day 2 I have another 5 employees, and day 3 also I have few employees. So basically I'll have to come to the demo input directory, read through all day level files and then merge it to a single file. So let's provide solution for this use case. For this I'll take tFileList component and then I'll choose the directory which is demo input. I'll say OK, and in the mask I would give it as day. Like all the file names which contain a day in it, I'll have to read it. So let me put regular expressions for it, that is star day star dot txt. So this will read all my day level files, and then I need a tFileInputDelimited to read those delimited files. So I already have the metadata, that is structure, which I had created in Excel, that can be reused here as well. So first I'll give my tFileList output to tFileInputDelimited. So it will iterate through all the folders and get me those 3 day level files. But every time it iterates, my file name changes. So day 1 will be in first iteration, day 2 and day 3 in the last. So it has to be dynamic. So I cannot hard code the path. I'll have to use the standard variables in outline section of tFileList. That will be tFileName with path. We'll have many other standard variables like only file name and the extension of that file. So now I'll remove the file name in the tFileInputDelimited configuration, and I'll use this standard variables which will give me the values dynamically. So tFileList1 current file path. In that current iteration, which file path will be available, that file path will be provided. And what is that file I'm trying to read? It's a delimited file and it is pipe delimited as we have created it in the previous example. And then now I need the schema. So only schema I can take it from the employee schema which I had created for an Excel. Same schema I will be able to copy here as well, but not the file properties. Only the structure I can copy. So even the structure which I had created for an Excel, I can reuse it for a delimited file. So now these 2 steps will enable me to read through the directory, get the file names dynamically, read all those 3 files from here. But then I will need tFileOutputDelimited, or it can be anything else as well. Like you can try with Excel or XML, whatever you want. And now what I'll do, I'll take the data. In each iteration, this data should come to this file, which I'm going to merge. And this one we can give it to output folder, demo output, and name it as employee merge. And even for that I can tell pipe delimited and schema will be copied. But the only setting where I have to do is, since I'm merging it, every time it will go to the same file, I'll have to choose this append header. And if I want the header to be included, I can use include header. But usually when I'm appending it, I'll go without header. So let me now run this job and check whether the merged data is available. We had 5 employees each in each of the file, and it should run for 3 iterations. That is one main thing because of the file mask. The directory also had other files. It should not consider those files. It should only run 3 times. So as you have observed, 3 times, and in each execution 5 rows has been provided to this file. So let me go to output folder and check if I have all 15 employees merged data in emp merge day level txt. So now I have all my 15 employee details which has been merged from 3 different files. So by doing these simple steps, we were able to only filter out the files which we need and then process them, read them, and then put it into a single file. So this is how you can make use of tFileList component in the file processing family. Now going forward in this example, the next component which we saw in the file family is tFileExists component. So once you have generated the merged file, say suppose there were no data for today or none of the day files were available, then obviously this file would not be generated, or it will be of 0 records or something like that. So every time when it is not generated, then we'll have to check whether that file is available or not, and then only proceed for your further transformations. The first step which you do is all day level files you are merging into one file, and on that one file you are going to apply transformation rules or something like that. Then let's do a use case for that to check whether that file is available or not, and then try out some messages. So for that, let me deactivate this section now. The very good option in Talend is a part of the job you can select and tell deactivate it so that they don't execute and you can easily debug where the problem is. So now we have already generated the main file over here, which is emp merge day level. So now my use case is to check whether this file is available or not and then continue working on it. Suppose, assuming that file will be always available, if I had written tFileInputDelimited to read this file, so I'll copy the file path over here, and then I need structure for it. So since there is no connection, structure would not be available. One more method is to copy the structure. Like I can say edit schema for this, where schema is already available. I can just select all of them and say copy, and I can come to my input delimited and edit schema. The paste option will be enabled. I can just paste it. So I got the schema ready for my input file as well. So this file which I'm going to read is pipe delimited, and I will simply put the contents of it into log as my previous example which we did in the beginning. So since the file is existing, this job would run without any problem. So let's run this job. So remember, only this activated part of this job is running. So it has read all the 15 rows and I have the output over here, right? But this will not be the case every time when I am providing solution for this use case, because someday, maybe in the weekend, all the files will not be available, something like that. So in the same case, if I go and rename the file here, say for example underscore backup, I'll name it as, so that that file will not be available in the same path which we had given in the job. In that case, when we run this job, this would result in an error because that file is not available. So it said it's 0 rows because I have not, you can see here, so it is not available. There are few components which will only put on this error and not kill the job. Suppose it is design thing which I have to maintain. If there is no data in this file, my job should not continue. So we have options for it. So I can see die on error. If there is any error, you can die. So since that file is not available, I don't want to proceed further because that is the main file which I have to read, and that is the source for all my upcoming components. So this will put down an error for you because that file is not available. So this should not be the case. Even then, if the file is not available, the job should successfully execute and it should give out some message for me. So for that case, we can use tFileExists. So before even I start this execution of it, I should control it by checking whether that file is not there so that the job does not result in error. I can take the file name which I want to check and give it to this tFileExists component. As we know, it will just check the file availability. If it is available, it would give me true. If it is not, it would give me false. So only in the true condition, I should execute the input component. So I'll take a run if and I'll give it to it because I'm conditionally controlling the workflow. So I'll also take tMessagebox, which is a component which will pop up the message based on the condition which we provide. So I'll take another if condition and I'll give it to tMessagebox. And this message box will tell me that file not found. This should be in the negative case. And now to define the positive and negative case, click on this if condition and then take the standard variable of tFileExists. So in tFileExists, there will be a one standard variable called exist. So I'm dragging and dropping it. If this is equal to true, then the file is existing and I'll take this path. And if it is not existing, then this standard variable will be equal to false. So in that case, I'll tell file not found. So by using this component, I'm able to not put down an error. So let's run this job and see. So in the case, now we have a case where file is not existing. So it should throw up an message box for us. So it says file not found. So without any problem in the job, successful job execution, but we got to know the file is not available. So let's execute the positive scenario. Like I'll change the file back to normal file name by removing the backup. In this case also, our job should execute fine by reading the file and putting it to the log. and not coming into the file not found message. So now it has taken this path and we have the output in the console. So this is the usage of tFileExists component. So the next component which we saw was tFileCopy. So once your processing is complete, you can move this file or copy this file to a different directory. Say suppose after this step your execution is completed, then I want to move this file which was there in output to processed folder or something like that. Okay, so I can go back and create a process folder and name it as demo processed, something like that. And I want, after the successful execution of this, I want the file to be copied to the process folder. So once it has put down the all the transformation is complete, I can just tell on component OK, copy the file. And which file I have to copy? The same file which we had generated, that is day level, but then I'll have to change the name. So I'll give the directory as demo processed, and then I'll tell rename and I'll give it as day level processed, something like that, .txt. So now after all my transformation rules, it should copy that into a different folder called processed. So we can come to know by reading that directory which all day level or month level is completed or something like that. So now let's go, and it has executed successfully. So if I go to demo processed, I have my day level processed file with the same data. The file name has been changed. So you can copy the files and you can change their names, all those stuff you can do using the tFileCopy component. So as simple as this. So these were the components which you saw in file family. So with these use cases, you should be able to visualize how easy or how simple it is to put down and use all your widely used file components family. So next family which we are looking into is the processing components, right? So I have used one EMP file in demo 1 where we have read the EMP details. So in the similar way, we have another file called tFile second input which has the country and state information. So I'll show you that file. So EMP details 2. So everything is same. So structure is different for this. So it has my EMP employee ID and state and country details for it, each of our IDs. So this is the ID, city and state column, right? To read this file again, quickly I will need to create the metadata because the structure is different. So I can tell under metadata, again create file Excel. So I would say emp_2. So it has read the empty columns as well. So I'll go and delete the empty columns in the previous step. So I'll just remove these extra columns and I'll say finish. Now I have the lookup file as well, which I can get the details of state and country of my employees, right? So I'll just drag and drop the InputExcel. So now we'll have to join these two data. So first I would like to demonstrate the tJoin component. So let me remove this tlog row and say tJoin here. Now I'll connect the main, which is my employee details, and then employee state and country details. I would again main, I'll take it and put it tJoin, but it will be converted as lookup row for this component, right? Because it is lookup for it. The second one which I join. The first one, whichever you join, will become the main, and the second one will become the lookup. So tJoin will have only options to join and take the columns from the lookup, right? So I can just tell include lookup columns in output, and then in edit schema I'll have to choose two files over here because I'm trying to take the column from the different file as well. So I'll tell all the columns from the file 1, and then in the file 2 I would need city and state. ID is my key, so I don't want it to come again. So I'll have now date of joining plus city and state as my output schema, and this output schema from where it has to take the column from. So ID, like this input column city, it should take it from lookup city, and in output again state should come in row2.state. The row 2 is nothing but this lookup identifier. So mapping has been completed. And what is the match? So ID coming from main row and ID coming from row 2 is the key. So that's all I have to configure, and I'll take the output and give it to this. The old structure was different, so it will show that schema is different. So I'll just come in here, tell edit schema. Since the input schema is different, that is, it is having 2 column extra, it is showing that warning. I can either take these two and move it here, or just say sync columns and this warning will disappear. So I'll say sync columns and it has taken care. And I'll change this file name to employee data master with all the data we are looking up from the lookup. And I'll just run this job. It will generate me the file which has employee details plus the details of their country and state from the lookup file. So the execution is successful. So let's see in the output folder whether I have the master file, emp data master. So if I open this file, I have all employees, state and country detail as well populated in my master. So this is how very simple steps we can use the tJoin component. And also, if there are any rejects in this joining operation, I can even capture the rejects by having simple option over here. So I have inner join with reject output. So I can just click on this and I can choose a file or even the log to capture the rejected records. So this will capture the rejected records and I'll tell them to put them in the table format. And now we'll go back and create one data so that it will not have the inner join. So let me add a new row so which will not match, and I'm saving this. And now I run this job again. I'll say append because it is already having the data. So now I'll run the job. And with this use case, we are expecting one inner join to be rejected. So it has not rejected anything because we have added the inner join reject in the lookup, which is not the use case. We'll have to add it to the source. So let's go and add it to the source. Why I'm showing this use case, whenever I added in the lookup, I was not able to capture it because in tMap, we'll have those options to capture them, which we'll be seeing in next example. So I'll just copy this and again do the same operation which I did there. And now again, I'll run the job. So I had 0 rows here in the reject before. So now let's see what will be the output. So now we can see one row has been rejected and it should be the row which we entered in the master, that is 1111. So it has rejected because it doesn't have any lookup value. So it is null for city and state. So this is the maximum capability of tJoin. So similar use case, we will do it for tMap. So I'll just remove tJoin and then I'll introduce tMap here. So tMap is a heavy component. What I mean by heavy component is the number of lines of code which will be added to my job when I choose tMap is more compared to when I add tJoin, right? So it has to go on use cases. If you are using this component only for the joining purpose without filtering, without altering the number of columns or something like that, then you can go to tJoin and make your job more optimized. But if you have some filtering criteria, expressions to be included, and the business rules to be implemented at column level, then you will have to come to tMap. So similar conditions. So connecting main to tMap and connecting lookup to tMap. And then have to generate the output over here. And to show the capability of tMap, I'll be adding one intermediate variable inside the tMap. So now I have the source and lookup. So with dragging and dropping the key column, I'm able to join these two. And after joining, I can drag and drop them to the output, saying again master, and then take all these 4 columns from the source straight away, drag and drop it to the target, and then take city and state from lookup, drag and drop it to the target. So I have my master structure ready. But then I want to introduce one more column which I'll be deriving the value for it inside the tMap itself. So I'll come here and add a variable and then I'll say email ID. And what I'll do, I'll take the first name and last name to this variable and then I'll create or generate the email ID. It is just for demo purpose. So I'm just taking my employee first name and last name. I'm not doing any validations over here. So first name plus, that is first name dot last name, append it with @edureka.com. So I'll generate an email for the employee. So this email ID I want it here. So I'll come here, create a same email ID for this, and then I'll drag and drop this email ID column to email ID. So it will be var.email ID, which will be coming here. So I was able to, change the number of fields, and I also deriving the value of it inside the tMap itself. So this is the capability of tMap. So now again about the tMap, we were telling it will be available to, filter the data, all those stuff. So I can also filter it by adding the expression editor. So I have to click on this expression editor, and I can say if I want to consider only employees which are there in particular city. So I'll drag and drop this city from my lookup, and then I'll have to check the data. So which city I'll have to consider. Maybe I'll consider city called Columbus. So I'll copy this value, come here and say only if it's equal to Columbus, then accept only those rows. Or we can even put dot equal to. In Java program, we can use row2 dot city dot equals this value. If it is true, only then those employees will be captured here. So this is filtering after the join. So join will not have any effect on it. So once the join data is coming here, it is getting filtered, right? And then I can create the same thing which we did it in tMap. I can create one more output telling rejects. So I can minimize this. In the rejects, I will only like to capture which ID got rejected. So I can just tell drag and drop the ID which got rejected. And then in the settings, I would just tell catch inner join reject as true. So this completes my settings for tMap. So I'll just give master to this. Again, one column is extra, so it would give me the error of different schema. So you already know how to resolve it. Just tell sync columns, and then I'll give rejects to tLogRow. And again, tLogRow previously had 3 columns. Now I have only taking ID. So here also I'll sync columns. And now let us run this job. So now we can see the same output of previous tMap whatever we used, but then same one row has been rejected, which was our expected output. But in the data only ID I have captured. So with ID I'll get to know what is that record. But in the output delimited, I will have my email ID generated. So emp data master is my file. At the end I'll have the appended data. So let's go and check whether I have the email ID generated. So you can see we have generated email ID for all the employees with first name and last name. So this is the capability of the tMap. So you can add the different columns over here. You can filter out the data. We have filtered only those data which are needed for our Columbus country. So we can check that as well. So you can see all the employees who are having email ID are from Columbus. So only those data we have generated the email ID, and others should not have it. So it starts from here. So before, other country is not having the email ID. So this is the capability of tMap, right? So similarly, after this data has been generated, we can filter out the data for only one country, and we can sort it out in alphabetical order or something like that. So data coming out from this output component, I can just give it to tsort row component, or before sorting I would filter it for certain condition. So I'll take tFilterRow, simple. It can give multiple filtering options over there. So I can just say same schema will be copied for filter. I can give the date of joining, or I can give the ID less than or something like that, so that I get a little bit of records. Or I can give the state. So state as ME for Columbus data, and inside Columbus only ME we are going to consider. So I can tell state equal to, within quotes I have to give this value ME. So it would filter out those data Once that is filtered, I can sort that into alphabetical order. tSortRow. So in tSortRow, same schema will be copied. So I'll say what is the sort column I need. Maybe the first name, and it is a alphabetical, and I want it in the ascending order. So this output, let us put it a delimited file. I'll just copy paste the same component and I'll use it here by changing the file name. I would just say the master filtered and sorted. So I can run this job. This covers the scenario for filtering and sorting, both of them. So now let's check the output. So it is the sorted output, Franklin first and Thomas next. And this is how you can use the sorting and filter components. So now we have the filter data, we have the master data, so it's according to our needs. So to introduce you to database components, let's first create metadata for database components. So under metadata, DB connections, I would just say create connection. And this would be for EMP database, so metadata EMP. And the database which you are trying to use here is MySQL. So I'll select MySQL and login. Let me give it as root. And since it is residing in my local, I don't have to give password. Server is localhost. And then the database name. Before I provide the database name, let me go and create a new database for our demo purpose. I'll say MySQL user root create database c_dem and then use database c_demo. So database, I can give it as cdemo here and just check. So connection is successful. So my metadata for DB connection is ready. So in the same job, I'll drag and drop my metadata. And this will ask for again which all components I can use them into. So I'll just say for now I need only tMysql connection. So I'll click on tMysql connection and it is available. So initially we'll have the connection done. Once the connection is successful, then only we'll start this process. So let me remove sorting now since we have finished that use case. So we'll end at the master data creation. And once this master data is created, as a next step, I want to load it to a MySQL table. So for that, tMysqLinput. So this will be a component. So I'll just put it on here. So once this whole subjob is completed, so that is on subjob OK, I'll give it to this component. And this component settings use an existing connection. I'll click on this to map to this connection as I've explained in the PPT, and we'll check which connection to use. And then we need schema for this, like what is the schema for the database. So if it is input, we'll have to give the schema. So what we'll do, before even coming to MySQL input, we will load this data however it is there in the master to tMysqL output. So let me for now deactivate this component. Whatever data is coming in the master, or either I can directly take it from tMap, which is master, and give it to my MySQL table. And here I'll tell use existing connection, which I've already created, which is EMP, and I'll give a table name called EMP master. And the action on table is like if table does not exist, create it, and insert is the command. And here only thing difference you'll see is we'll have the DB type as well. So the same schema and corresponding DB types will be populated. So with this simple steps, I'll be able to load my data to my database as well. So let's run this job. So now the filtered data has been populated to this table. So now if I go and check my database, whether we'll have data. So that is the first question. So let's check whether the table is created or not. So EMP master table is created. So now I'll tell select star from EMP master. So there is no data because we have not committed the data, right? So I'll use tMysql commit and I'll commit this data, right? So on component OK of this, commit the connection which is you're pointing to and don't close the connection. And also I'll remove the filter over here so that I get all the data, not only Columbus for this use case. So I'll remove this condition. And now I'll again rerun this job. Here table is already created, so it will not create the table. It will just check whether it is existing or not. And then it will try to load all the data and then commit. And once all the data is loaded, we will read it from the database by providing filter only for Columbus or that state. And one more use case will be completed for the tMysql input. So let's see if this job executes successfully. So it has executed successfully. So let's go and again check. So now you can see the data available in the table. So now quickly create a use case for input. So I'll activate this component, and why I had not given the metadata for it is there were no table available in database. Now we have created it via job itself. So what I have to do to get the structure, I have to come to temp schema, which is database schema, and I have to tell retrieve schema. So it will retrieve schema of the tables which we provide. So since there is only one table, I'll just go ahead. So it has so many tables in this schema, and I can select this table which I want to select the schema. So I'll say finish. So in my input component, now I can provide what is the table and what is the schema. So I can just tell schema from repository, and then I can select schema for my EMP master. And I can also tell guess query. So it will create the query for me, and I can filter out now by adding filter directly where emp underscore master dot country city equal to Columbus. Only that data I'll retrieve. Let's see whether this is syntactically correct and it executes. I'll just log the data over here. You can actually deactivate this section because already data is populated, and I can execute only this part. So let's run this job and see whether my filter condition works directly embedded in the query. So now we can see the filter has been applied, and only those employees which are from Columbus has been populated over here. So this is how you can simply use the tMysql input, and out of large data you can filter out and get those data without any problem. So this is all about your database components. So hope you like this video, and to get deep understanding of each of the components step by step, please join Edureka Talend Big Data Training and take a step up in your career. Have a good day one and all.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!